Hey everyone, here's our math problem for today. This is our daily math Olympiad training. Let's say we are given this cube root of x plus 13 minus the cube root of x minus 13 equals 2. Find the value of x. You can pause the video and try this problem first. Now let's solve this problem together. Let's inspect the given. We have two terms here and both are cube root, and in the radicand we have x plus 13 and x minus 13. So they're almost identical except for the operations. Now when we have problems like this where the term is more complicated, one technique is to substitute a variable to simplify the equation. So let's use the variable a to stand for the first term and another variable b to represent the second term here. Then let's simplify the first equation. Raise both sides of the equation to the third power, and simplifying, this index 3 and this exponent 3 will cancel each other out, and so we have a cubed equals the radicand x plus 13 at the left. Then going to the second equation, we also raise both sides of the equation to the third power, and simplifying, we have b cubed equals x minus 13. Let's save these results, and we are going to use that later on. Now let's go back to the given equation. We already know that this first term is a, the second term is b, so we can now represent the given equation in the form a minus b equals 2. And let's save this result as well. Let's go back to these two equations and let's solve this simultaneously by subtraction. So let's subtract the first equation by the second equation, and here is the result. For the left side of the equation, x plus 13 minus the quantity x minus 13 at the right side. Then let's remove the grouping symbols. There's no problem when the grouping symbol is preceded by a plus sign or there is no sign here. Just remove the grouping symbol. But when you have a minus sign preceding a grouping symbol, think of having a negative 1 here. So negative 1 times x is negative 1x or negative x. Negative 1 times negative 13 is positive 13. Then x plus negative x will result to 0. So what's left at the right side is 13 plus 13 or 26. And again, let's save these results and let's focus here now. Notice that a cubed minus b cubed is one of those special products, and its value is equivalent to the quantity a minus b times the quantity a squared plus ab plus b squared. So this difference of two cubes is now this part here. We just copy the right side. Then we simplify. We know that a minus b has a value of 2. Replace that. Then divide both sides by 2 to get 26 divided by 2 or 13 at the right side, and we just copy a squared plus ab plus b squared at the left side. Then let's save these two results as well. So here is our repository of what we know so far. Now let's recall that when you have a cube of this binomial a minus b, that is equal to this value here. This is an identity. This is one among those identities that you need to remember in algebra. Let's rearrange the terms here first. Let's put together this a cubed minus b cubed side by side because we are going to group them together. And in here, there's a common factor of negative 3ab, and this a minus b is of course equal to 2. So let's group this together. We now have one group here. Let's factor out negative 3ab. So negative 3a squared b divided by negative 3ab, the result is a. This last term divided by negative 3ab, the result is minus b. We know that a minus b is equal to 2. So we can replace this a minus b and this a minus b by 2. Then 2 cubed is 8 and 3 times 2 is 6. Simplifying, we have 6ab equals 26 minus 8 or 18, and divide both sides by 6 to get ab equals 3. So we now know that the value of this ab is equal to 3. Let's go back to this value and let's substitute now 3 for ab. This now becomes a squared plus 3 plus b squared equals 13. And subtracting 3 from both sides, we have a squared plus b squared equals 13 minus 3 or 10. And let's remember again these values that we are going to use later on. We need an expression for a squared plus b squared. So let's recall again another identity. This time, the square of a binomial a plus b. We have this a squared and this b squared here. we already know what's the value of a squared plus b squared. That is equal to 10. And we already know that the value of AB is equal to 3. So substituting those values, we have the square of the binomial a plus b equals 10 plus 6 or 16. And taking the square root of both sides, we have a plus b equals plus or minus 4. This means there are two possible values, either a plus b equals 4 or a plus b equals negative 4. And we are now closer to our final answer. So we have a plus b equals 4, but we know also that a minus b is equal to 2. So we solve these systems of equations. Let's start with the first one. Adding these two equations, we have a plus a or 2a and b plus negative b is 0. 4 plus 2 is 6. So there is no variable b anymore. And finally, we have the value for a, which is equal to 3. If a is 3, we can solve for b. So this a is equal to 3. Substitute 3 for a. And we have b equals 4 minus 3 or 1. For the second equation, we also add these two equations together to get 2a equals negative 2 or a equals negative 1. And solving for b, b is equal to negative 3. So we now have two values for a and two values for b. So we now need to see which among these values will satisfy the given equation. So if a equals 3 and a is equal to the cube root of x plus 13, so we now substitute 3 and raise both sides to the third power. This is the simplified form. Then 3 cubed is 27, and solving for x, we have x equals 14. And when b is equal to 1, this b becomes 1, and we raise both sides of the equation to the third power to arrive at the simplified form. And solving now for x, x is equal to 14. So we now have the values for x. Both of them are 14. In this case, let's just take one value for x. Then, using now the second result, a equals negative 1 and b equals negative 3. Again, replace this a with negative 1 and raise both sides of the equation to the third power to arrive at this. And negative 1 cubed is still negative 1. And subtracting 13 from both sides to arrive at x equals negative 14. The same results you will arrive at the right side to arrive at x equals negative 14. So let's just take one of those values. So here are now our results. We have x equals 14 and x equals negative 14. To check if we have an extraneous root, let's substitute these values for x in the original equation. And if x equals 14, we arrive at a correct equation. And when x equals negative 14, we replace again each instance of x with negative 14. And simplifying, again, we arrive at a true equation, which means that x equals positive 14 and x equals negative 14 are the roots of this radical equation, and that is confirmed if we are going to look at the graph. This red curve is the graph of our given radical equation. The intersection between the graph of the left side and the line y equals 2 is at negative 14, 2 and positive 14, 2, giving us two values for x. X equals 14, x equals negative 14, and y are both equal to 2. So this confirms that our answer is correct. So thank you very much. This is Lando Assistant, and we hope to see you again in our next math training here at Math Avenue.